But yeah, I'll just basically get started on the SmartDose. We have the second version that we are more or less officially launching these days, SmartDose version 2. It's not exactly the correct name for it. If we're being pedantic, it's actually version, I think we're at like 4.41 or something at this time. But that doesn't really roll off the tongue if you're trying to do marketing. So we've kind of rebranded this to version 2. And it's got a couple changes compared to the one version that you are probably familiar with. And I'll slowly introduce those. But before we get to that, there's a little bit of a basic introduction on the processes by which we are working. Those, of course, being coagulation and flocculation. So wastewaters, especially those from industrial sources, generally contain suspended solids that are stabilized. So small particles of organic material or something like that, which are, well, perfectly happy being in suspension. They don't settle well on their own. And that happens because most of the time they're negatively charged and they repel each other. So they don't tend to aggregate and settle as a whole. They just want to be individual particles. When we add a coagulant to a solution, and most often we use metal salts for that, like ferric chloride, polyaluminium chloride, or aluminium sulfate, those coagulants can then form a positively charged complex that can neutralize those particular charges. It's a rather complex bit of mathematics behind it. There's a lot of literature on how this process exactly works, and well, there's quite a lot known about this. It's not a new process, but even then, with all of the literature and research that exists, it's not exactly a fully understood concept. Well, we know a lot of empirical things about it, and if you ask somebody with experience, they'll be able to say, oh, for, say, a chicken slaughterhouse wastewater, you would normally use 0.6, 0.7 liters per cubic meter. But it's not like we have a full calculation model that can accurately predict for a certain wastewater what the correct dosage of a coagulant would be. To that point, we're still kind of trying to figure out what the correct solution would be. We do know some general things, and that is the mode of action for a coagulant. So those negative charges I just talked about, those are the big problem that we want to get rid of. We add some kind of a metal salt. It forms various hydrolysis complexes that can then be used to bridge those charges and clump those particles together. This gives us relatively small flocks, and we then use a flocculant or a polyelectrolyte or something like that to bind those bigger flocks together so that they are easy to filter, float, or settle out of the solution. This works quite nicely, but there's a big question going on there, and that is how would one determine what the correct dosage of a coagulant is for any particular water? It's very difficult to predict that, so the industry standard method is to do a jar test, which is a fancy way of saying, well, just get a couple of jars, throw in a couple of different dosages, and see which one settles the best. That is the current industry standard way of determining the dosage for a coagulant. There's a couple downsides. The first being it does take time. You need somebody with the relevant experience to figure out what those dosages should be. I just got a Roberto was the one who just joined as well, right? Yeah.
Yes, sorry, I was kicked out by my computer.
Oh, the wonders of modern technology. Can you see the presentation now? Is everything all right?
Yes, thanks.
Okay, good. I'll continue on from where I was then. Yeah, as I was saying, for jar testing, to do that at a particular bit of wastewater, it takes you some time to do that. It's not an instant measurement. You have to perform the actual jar test and make your determination based on that. And it only reflects what the correct dosage is for that little bit of water that you're testing right now. If you have a client where the wastewater at the start of the day is different from, for example, in the afternoon or in the evening, then to be fair, you would need to do multiple jar tests to figure out what the dosage is for each moment. And that's a little bit prohibitively expensive. So people don't generally do that. So what people often do is just preventatively overdose coagulant to make sure that it's always correct. And the principle of the SmartDose is that you don't have to do that anymore, that you can constantly reflect the pollution level in your water. So it's essentially just a way of automating that process of jar testing. And in doing so, we get images like these. So these are little tubes that we have inside the SmartDose where you can see how well the coagulation is going at any given moment. And we have some fancy algorithms behind it which help us figure out what to do with that information, of course. So the basic premise is that we have a sensor in there. That is the USAF 22 or the USAF 12. It's a particularly expensive bit of stainless steel, which is a near infrared / visual light absorption sensor. It's a really fancy way of saying that there is a light on one end of a clear tube that shines a specific amount of light through it. And then on the other side of that light, we just measure how much of it we can still see. So if I have 100% of my light shining through and half of it is taken up by some of the water or the particles in there, I would measure that the absorption of the water is 50% or 20 or 80 or something like that. And from that information, we can glean a lot of information. So it can tell us, for example, whether there are particles going past the sensor. If the absorption is wildly varying, so suddenly it's going to 100%, then 0%, then 100, then 20, it tells me that there are some particles going past, which probably are flocks, which is good. I'd like that. It can also tell me that the water in between all of those flocks has a particular shade or a particular absorption. Is the water still very turbid, or maybe it's getting quite clear, it's a little bit yellowish? That's something that we can figure out from these kinds of sensors. So that's how we normally operate here. Now, the tricky thing is, how do I translate that to my desired dosage? Well, the only thing that I know is that if I vary my dosage, I'm going to get a graph of absorption that looks a little bit something like this. So at some point, if I'm not dosing any coagulant, my water is just going to be completely turbid, right? It's full of suspended particles. I can shine as much light as I want. I'm not going to measure anything on the other side. Then there comes a point by, let's say, 0.5 liters per cubic meter, where suddenly coagulation is working quite nicely, and I start seeing clear water. So very quickly, you see a sharp drop in how much of the light is absorbed by the water. Then from there on, there will be some stretch where adding a little bit more coagulant will lead to slightly clearer water still, which is still increasing the efficiency of your treatment plant, but at this point, it's not really, it's not really interesting to add that much coagulant anymore, because you need to add a lot of coagulant for relatively little gain. It's basically the law of diminishing returns. After that, there's finally some point where I will have so much coagulant in my water that I'll start measuring extra absorption again, because I'm just measuring the coagulant. We'd rather not be in that section. So this point here in the middle is the acceptable dose that we would want to have. And from an economic perspective, it's most interesting to be somewhere near the left side of that. So we're almost trying to aim for roughly this point in the graph. So far, so good, but the problem is that this graph is not universal for every client or every wastewater. I know that it has this shape, this profile. It's always going to be there, but maybe for one client, it's moved up a little bit higher. So the cleanest water will still have almost 50% absorption. Or maybe the entire graph's a little bit squished to the left because this client just doesn't need that much coagulant. I can't predict this, but I do know that this shape is there. So that's what we built the SmartDose to look for, this particular shape in the graph. So in the ideal situation, the sensor continuously sees particles going by, which are flocks. We filter out those measurements. We do take into account that there are flocks. That's a good thing, but then we don't take those values into account for our measurement. And we then take the absorption values of the clear water in between, and we try to infer something from that. Of course, we also need to be working in the less than ideal situation where maybe I'm dosing way too little coagulant or the pH is incorrect or something, which is where I would just have water that looks terrible. At that point, all of my measurements are more or less 100% absorption, and I would have to make a more drastic choice to increase or decrease my dose because apparently I'm quite far from where I should be. And of course, anything in between that is also something we need to consider. So here you have a number of pictures where coagulation does seem to be taking place, but it's not flocking too well. Perhaps the dosage of the polymer is incorrect, or the pH, or we are just not quite at the correct dosage of coagulant, so we need to increase a little bit more, but we're getting there. These kinds of profiles, where if you look at a picture like this, it's quite easy to see what's going on, are pretty difficult to get out of a sensor. So there's a lot of math involved in getting these kind of inferences out of there, but I won't bore you with the details. What you do need to know is that the system now works with a decision tree which has 7 distinct outcomes. And the reason it does that is it takes into account what it has been doing before in the past 15, 30, 45 minutes, so that it doesn't just make a dosage determination based on what it sees at this moment, but it figures out that, oh, I've noticed that my water is very stable, so I can decrease a little bit further, or, ooh, the water is very much fluctuating all over the place, so I'm going to be a little bit more cautious. But these kinds of decisions, as far as I'm concerned, is what make a SmartDose truly, well, smart. It's quite important. It's in the name. So we keep constantly trying to ride that edge of what constitutes good coagulation. And one of the fancy new things that we have is a couple new settings. So our client can now determine how closely we can follow that edge. To do that, we have labeled these controllers the performance and the eco mode. I think you can imagine that the eco mode is the setting in which you have the lowest coagulant consumption, the lowest sludge production, but also the SmartDose isn't quite as critical of worse quality water. Sometimes it will let something slip past. If you want to be sure that you always have the cleanest water, you of course set it to performance mode, where it becomes very critical of the quality of the water, which will lead to increased coagulant costs, but it will absolutely make sure that your effluent is always clean. Under the hood, this is just the same controller with a different set of parameters, and it more or less translates to that we are looking for a certain position on this curve. So in the eco mode, we're looking for just about that edge where the coagulation is starting to fall apart. Whereas for the performance mode, we're looking for the slope at a point where we're pretty safe, we get very clean water, and if I decrease or increase the dose a little bit, it doesn't have too much effect on the quality of the water. So in summary, eco controller, lowest coagulant consumption, but slightly turbid water. Performance controller, more expensive, but you get very clean water. In addition, we now have a new small dashboard on the HMI, which is nice for our operators to have. Gives you a couple of key performance indicators. It makes it a lot easier for us as well to monitor what the SmartDose is doing. I see we got a late entry. Beata, good afternoon. Hello? I assume she's in. We'll just continue. Right, what was I? All right, new dashboard. So it's a lot easier for us to see why the SmartDose has made a particular decision now, because it logs those decisions as well. So in the previous versions, it was sometimes difficult to, well, debug it or fine-tune it if a client wasn't quite happy with the performance. So now we can see much better why it made a certain decision and fine-tune it accordingly. We also have some more user-friendly controls. We have a built-in cleaning system where every 30 seconds or 30 minutes it has a standard cleaning cycle, but also when you have to do a manual operation, you can turn it on the cleaning mode so it will continue to dose coagulant. We have some better data logging, which helps us debug and fine-tune systems, and we have a camera now by default, which is not important for the process. The camera doesn't actually do anything, but it's quite useful for us. If I'm trying to fine-tune something and I log in from a distance, being able to just see a picture of the flocks right then and there, it's very helpful. Right, with that out of the way, I think the most important thing for well, our sales department and I suppose our clients as well is what do you need to know if you want to sell a SmartDose? And whether that's the new version or the old version, I think the basic premise is more or less the same. You sell it for coagulant savings and such. But a couple of key differences are quite important to know. Now there's a quote here that I thought was quite, well, but it struck a chord with me. Cut costs, not corners. I think that's a good marketing slogan for the SmartDose. It keeps coming back to my mind, but it is made by ChatGPT, so do with that as you will. But it is more or less what I think that the whole point is behind the SmartDose. You make an investment for something, which will, in the long run, of course, decrease your operational expenses. So let's say that you have a client who already has a SmartDose, one of the older versions that's running on the older software. If you want to tell them why they should get the new one, well, it's not actually that shocking. It's just SmartDose version 1, but a little bit better. Slightly more user-friendly controls, more consistent controllers. You could possibly get them the software as an upgrade for 8,000 to 10,000 euros, but it's not the most interesting kind of client for the new SmartDose. If you have a new client, then it's of course a lot more interesting because they can significantly benefit from a decreased coagulant consumption, a decrease in sludge production, also neutralizer. So if you're not overdosing as much acidic coagulant, you don't need as much sodium hydroxide to neutralize it again. The process becomes a lot more reliable. You get some useful insights in it. And you get all that for 50 or 60,000 euros, depending on which particular edition of the SmartDose you get. Now, if I were to go to a client and say it costs you this much euro, that's not quite the number that they want to talk about. They want to talk about payback periods. That's a tricky figure because it really does depend. It's not just one figure. I can't say for a SmartDose it pays itself back in 1 year or 2 years or whatever. It depends on a lot of client-specific things. For example, what exactly are the prices that you're currently paying for your chemicals? Are you in a country where ferric chloride is very expensive? Well, then, of course, it's much easier to recuperate that investment. The same goes for sludge disposal costs. What is your normal coagulant dosage? If you have a system where you are dosing maybe, say, 1.0 liters per cubic meter, it's much easier to recuperate that investment than if you're dosing 1/10 of that. Same goes for your total wastewater flow. The SmartDose is not really related to the amount of water that you're treating. Whether you're treating 1 cubic meter or 10 or 100 doesn't really matter. So the more wastewater you have, the quicker it is for you to recuperate that investment. So it's not really easy to generalize that, but I'm going to try regardless. So, of course, it's most effective when you have high costs at some point or some kind of very critical application where you need to make sure that you're always dosing the correct amount of coagulant. So if you have a high normal coagulant dosage, a very variable water composition, we have a couple clients, for example, in Sweden. They have a salad factory where they have a lot of different kinds of products that they're treating. So one day they might have very starch-rich wastewater, then something that's very fatty from all of the mayonnaise that they're cleaning. So one day they need something completely different from the other, and they can either get an operator standing next to the treatment plant the whole day, monitoring everything, or you can get a SmartDose. Also, if you have very stringent effluent requirements, so you're reusing your water, for example, and you absolutely want to make sure that you have a certain degree of removal or that there is no leftover coagulant afterwards or poly, then a SmartDose is, of course, also more interesting. And generally, any time that you have a high market price for chemicals or sludge disposal also helps. I think in the Netherlands, the sludge disposal costs follow a bit of a trend, and that's based on when the amount of sludge processing facilities are increasing or decreasing. Every couple of years, a couple of them go bankrupt, then the price for sludge disposal increases, and a couple new ones pop up, and it goes down again. So it's almost like a sine wave that you can follow. We do have a small Excel sheet for you with which you can estimate the payback period. Unfortunately, it is in Dutch. If it is something that you're interested in, I can translate it for you and send you the English version. But if that is the case, then please send me a message after the meeting and I'll make sure that happens. But it's a quick calculation tool that helps you estimate what the current pricing would be for a client based on their coagulant consumption, sludge production, etc. And then it figures out for you what the simple payback period is. We have a couple of inputs here that help you figure out what the client is currently paying for their coagulant consumption. Then we have something at the bottom here that gives you some figures on the savings. You probably shouldn't really touch those because that's more or less a given. And then from that, we calculate two different sets of figures, a case A and a case B, one without and one with a SmartDose. So some of the costs will decrease, like your coagulant usage and your sludge production. Sorry, was that a question? Suppose not. So yeah, some of the costs will decrease, some will increase, and hopefully at the end of the time, you'll have some amount of savings. So we get the simple payback period from that. Not really considering inflation or interest or anything like that, but hopefully the simple payback period will be within the order of 1 or 2 years. If it comes out to being something like 6 years, then it's probably not the most interesting case in the first place. But this is an Excel sheet that helps you figure that out a little bit easier. There's also a couple of soft benefits to a SmartDose, which I haven't really mentioned yet. But a big one is that if you have a very variable process where normally your operator spends a lot of time fine-tuning the treatment facility, that operator now has a lot of time to do other work in your factory or your slaughterhouse or wherever you happen to have a wastewater treatment plant. So these kinds of benefits are a bit difficult to put a price tag on. It's not something where I can say, oh, this is 50,000 euros worth of free up operator time, but it is something that I consider important, so definitely relevant to mention. There's also a couple more things you need to keep in mind, and those are mostly the fact that the SmartDose is not applicable to any and every situation. It has its limits, of course. So it only works for certain processes. A main requirement is that it is a physical chemical pre-treatment facility in the first place. It works really nicely for automating coagulant dosage, so it's not useful for other kinds of coagulants. I know that this is kind of a simple answer, but I've had it before where people think that SmartDose is something that automates all kinds of dosing. It just works for coagulants. That's maybe not the correct name for it, but just use it for coagulation. We also prefer only to have it for pipe flocculators. It technically also works for mixing tanks, like we have a lot of those in Germany. But the mixing tanks have a larger retention time, and therefore the response after changing your dosage is much more delayed, and it gets drawn out a little bit more. It's not quite as defined as it would be here. So yes, it does work for mixing tanks, but not quite as well as it would for flocculators. So preferably, we don't really do those cases. If you have a pipe flocculator, it's quite useful for us to have a pH measurement at the very least, preferably also some way of correcting it, so a sodium hydroxide pump, but at the very least having a measurement is quite useful. Reason for that is that coagulation is very pH dependent, and if I don't have any way of knowing what the pH of the water is, I can't quite see whether any particular moment the coagulation is going wrong because I'm dosing too little coagulant or because the pH may be really high. To give a very extreme example, we have one client where every evening they have some cleaning water that comes past, which has a pH of 13.5. Well, that's the kind of pH where it doesn't really matter whether you dose 1 liter per cubic meter or 1.5 or 2, you're not going to coagulate well. That's just a waste of coagulant at that point. There's no way for us to control the pH there. So what I want to do at that point is, well, I know this is just about 30 minutes, so I set certain limits to the pH where if the pH increases above a certain point, I just take my hands off the controls and I'll wait for it to stabilize again and then continue with the coagulant dosage. There's not really any point for us to waste coagulant in the meantime. If possible, having a flow meter on the influence side is also preferable because we're trying to figure out a dosage relative to the amount of water that you're treating. It's not a definite requirement that we have a flow meter, but it is preferred. The alternative is that you have a system with a very consistent flow rate. So if you have a client where the flow rate is always about 40 cubic meters an hour, maybe sometimes it's 45, maybe sometimes it's 35, but it's within those orders of magnitude, then that's fine. But if you have a kind of process where the flow rate changes from 10 to 40 cubic meters an hour, then some kind of flow measurement is required for us. We also prefer that to be as few start and stop moments during the day as possible. If you have a system with a very small pump pit or a small buffer tank, for example, where I can't exactly get consistent flow going, that's just not a system where we can have any kind of controller stabilizing over time. It takes about 5 or 10 minutes maybe for the system to stabilize after it starts up. So if I'm only pumping water through my facility for 20 minutes, then proportionally half the time I'm not really controlling too well. So that's not really an interesting case for a SmartDose or any kind of controller for that matter. So the ideal case looks more or less like this, where we have an influent flow transmitter, a pipe flocculator with coagulant, pH control, and flocculant dosage. And we siphon off a separate stream for the SmartDose. We figure out what to do with the dosage. And finally, the whole thing goes to a flotation unit. And hopefully we get some very clear water at the end. A couple of things I also quickly wanted to mention is that the version 2 that we're launching now is an improved version, the older one. But we're not just done yet. We're still working on a couple of new things. So we are developing a rather high accuracy, state-of-the-art It's quite a mouthful. Sorry, I'm not going to go through the whole thing, but I'll make it a little bit shorter. We're working on a neural net, image recognition. So you might remember that a bit earlier I showed some pictures of that little tube in the SmartDose where you can just see whether the flocks are forming nicely or not. If I ask you or me or some operator to have a look at that, we can instantly tell whether or not we are having good coagulation. The sensor we're currently using doesn't quite have that instant recognition. It needs to gather some data for 60 seconds and then draw an inference from that. So if we can get a neural network trained on training images, it would be quite nice for us to be able to use that. It's a particularly good reason why we'd like to do that, and that's because the sensor that we're currently using is quite expensive. So if we can replace that with a camera, we can get the investment cost down quite a bit. But that's for the future, so I'll have to plan a separate webinar when we have that worked out. But suppose that will be 6 months or so.